In this calculator tutorial, I would like to show you a couple basic ideas related to derivatives. First of all, as an example, I'm using the function y equals 4x squared minus 6x minus 1, and pointing out that it has the derivative y prime, or dy dx equals 8x minus 6. Obviously, in your Calc 1 class, you learned some rules about derivatives and how to calculate that derivative analytically. You also talk about the idea that a derivative is a measure of the rate of change of the function. One graphical interpretation of the rate of change is a slope of a tangent to the curve. For this particular example, the curve y equals 4x squared minus 6x minus 1 will have a slope of a tangent for any point at the curve given by the equation, which is the derivative, y prime equals 8x minus 6. And that's the statement I'm really trying to make here. The derivative gives us the slope of the tangent to the curve at any point. In these two examples down here, I'm using that equation of the derivative to find the slope of the tangent to the curve at two particular points. For example, the slope of the tangent to the curve at the point 1, negative 3 is given by plugging 1 into the equation of the derivative. The slope of the tangent at that point would be 2. And as a second example, I'm looking at the point where x equals negative 1 on the equation 4x squared minus 6x minus 1. The slope of the tangent at that point would be negative 14. Two ways that I want to show you to verify that work. So first of all, let me go into y equals and graph our curve. Y equals 4x squared minus 6x minus 1. And I think I'm in a standard zoom here. Yeah, looks like I'm in a standard zoom. So one way to verify the slope of the tangent at x equals 1 is the following. Above the trace key is the calc menu. I'm going to do second trace. And number 6, you'll see right here is dy dx. So if I choose to calculate dy dx at, let me punch the number 1, the calculator is going to, at x equals 1, find the derivative of the curve, the slope of the tangent. And even tells me at that point, here's the slope of the tangent, verifying the work we had here. It even nicely shows me the point on the curve, 1, negative 3. Of course, it doesn't tell me the y value is negative 3, but it shows me pretty much where that point is. So to verify the slope of the tangent at x equals negative 1, I'll do the same thing. Let me do second trace, go to the calc menu, I'll punch number 6 to calculate the derivative, and I'll hit negative 1. Click enter, and there is the slope of the tangent at x equals negative 1. Another way to do really the exact same thing, let me hit second mode and quit to my home screen. What I'm going to do this time is use the numerical derivative feature built into my calculator. So under the math key, math number 8, if I punch the math key and I go to number 8, you'll see nderiv. This stands for numerical derivative. And what I'm going to do is tell it to find the derivative of the curve 4x squared minus 6x minus 1. And I want to take that curve, differentiate with respect to x, and evaluate it at x equals 1. So the nderiv feature of my calculator requires 3 inputs. It requires the curve I'm going to differentiate, the variable of differentiation, and the point at which I want to evaluate the derivative. And when I hit enter, there's my slope of 2. I'll do this again. So let me do math 8. Math 8. I'm going to find numerical derivative of the curve. Now instead of punching the equation of the curve, what I'm going to do this case, remember that the equation was in y1. So when I come back to my home screen, what I'm going to do is instead of typing the equation, I'm going to go to the vars key, which stands for variables. I want to call out a y variable, so I'm going to click my right arrow once. In this case, I want to call out a function. Let me punch number 1, and in particular this example, I put my equation into y1. So let me call out that equation. So here's the nderiv of y1. I'm going to differentiate with respect to x, and then I'm going to find the derivative at negative 1 to verify our other example, which was negative 14, which is what we got down here. So graphically, under second trace, the calc menu, I can find a derivative, or numerically on my home screen, I can find a derivative in the two ways that I just illustrated. One other idea that I want to show you is that the calculator can actually graph the derivative for me. So let's suppose I wasn't really sure this was my derivative, and I want to graph the derivative. So here's what I'm going to do. I'm going to actually move my blinking cursor onto y1, hit enter, and turn that equation off for just a moment. Then I'm going to go to y2, and I'm going to graph the derivative of y1. So I'm going to go math 8 and call out the inderiv to the y2. Okay, again, my blinking cursor was in y2, and I did math 8 and I called inderiv into y2. So I'm going to take the inderiv of y1. So I'm going to do vars, arrow to y vars, call out function, call out y1. Or I could just type the equation 4x squared minus 6x minus 1. So I'm going to take the derivative of y1 with respect to the variable x, and instead of typing in, let's say, x equals 1 or x equals negative 1, what I'm actually going to do is type in the variable x. So what I'm actually telling the calculator to do here is find the derivative of the curve y1, differentiate with respect to x, and evaluate the derivative for every value of x. Instead of one particular value of x, all values of x. And what it will do when I hit graph, there's the graph of my derivative. Now that should be the line y equals 8x minus 6, right? That is the derivative. So let me go in here, and under y3, I'm going to type the equation, get my blinking cursor down to y3. I'm going to type the equation 8x minus 6, just to make sure that's the same equation. So when I hit graph, boom, there was y3. Now obviously I didn't see it graph because it lied right on top of my other curve. But just to be extra careful, what I'm going to actually do is go to the table. Let me hit second graph, go to the table, and I can see that y2, which was the inderiv, and y3, which was my equation, 8x minus 6, these equations match exactly. So for each value of x, the numerical derivative and my derivative are identical. And so graphically, they're lying right on top of each other. And those are some basic ideas about derivatives on the graphing calculator.